Good evening all. Last class we have completed question number 29. This class will start question number 30. So what is the question given? F of x is equals to 5 where x is less than or equal to 2. If x is less than or equal to 2, f of x equal to 5. Then ax plus b, x is greater than 2, less than 10, greater than 2, less than 10. Then the value is 21 if x is greater than or equal to 10. Clear? So it is given that the value, if the function is continuous function, we are going to find the value of a and b. It is continuous means less than 2 continuous, equal to continuous, between 2 and 10 continuous, equal to 10 also continuous. So I am going to use the continuity at x equal to 2 and continuity at x equal to 10, because less than 2 different function, greater than 2 different function. Similarly, less than 10 different function, greater than 10 different function. So I am using the continuity at x equal to 2 and x equal to 10. First, I am using continuity at x equal to 2. F of x is continuous at x equal to 2. So we can say that LHL is equals to RHL is equals to f of 2. LHL is equals to RHL equal to f of 2. So now write the definition of LHL. So definition of LHL. What is definition of LHL now? Limit x tends to 2 minus f of x is equals to limit h tends to 0 f of 2 minus h. So what is the value of f of x here? F of x in this less than 2 case is 5. So f of 2 minus h also equals to 5. So now applying limit h tends to 0 f of 2 minus h, that is equals to limit h tends to 0 f of 2 minus h value equal to 5. So LHL is equals to 5. What about RHL? Definition of RHL. So limit x tends to 2 plus f of x is equals to limit h tends to 0 f of 2 plus h. So f of 2 plus h, what is the f of x value in this case? Greater than 2 case, the value is ax plus b. So f of 2 plus h value will be a of 2 plus h plus b. Now apply the limit. So applying limit, we will get limit h tends to 0 f of 2 plus h. F of 2 plus h equals to limit h tends to 0 f of 2 plus h value is a into 2 plus h plus b. So now applying limit, what will come? H equal to 0, 2 into a plus b will come, that is 2a plus b will come. We know that LHL equal to RHL equal to f of 2. So from the definition 1, so from the equation 1, we can equate this. LHL equals to 5, RHL equals to 2a. So we will get 2a plus b equal to 5. This I can take it as equation number 2. Clear? Similarly, we can prove f of x is continuous at the point x equals to 10. So at x equal to 10, LHL will be equal to RHL is equals to the value of the function f of 10. Clear? So now find the LHL. So same LHL definition I am going to use here. So limit x tends to 10 minus f of x. Limit x tends to 10 minus f of x equals to limit h tends to 0 f of 10 minus h. So what is the value of f of x in this case? Less than 10 case, ax plus b. So f of x equal to ax plus b. F of 10 minus h will be a of 10 minus h plus b. Clear? Now apply limit h tends to 0 f of 10 minus h is equals to limit h tends to 0 f of 10 minus h value is a of 10 minus h plus b. Applying h equal to 0, what will come? 10A plus B will come. So 10A plus B is my LHL. Clear? So now find RHL at x equal to 10. Right hand limit, definition of right hand limit extends to 10 plus f of x is equals to limit h tends to 0 f of 10 plus h. So what is the value of f of x in this case? Greater than 10 case, f of x value is equals to 21. Similarly, what is the value of f of 10 plus h? F of 10 plus h also equal to 21. Apply limit h tends to 0 f of 10 plus h equals to limit h tends to 0 f of 10 plus h value is 21. Applying limit we will get 21. So our RHL is equals to 21. So this equation we can take it as 3, that is LHL equal to RHL equal to f of 10. So the equation 3 implies we will get the value of the third equation value. So we will equate the LHL and RHL now. So what is LHL? That is 10A plus B, 10A plus B equal to RHL equal to 21. So this is our equation number 4 we can take. So we are going to solve equation 2 and 4. So equation 2 implies 2A plus B equal to 5. 2A plus B equal to 5. The value of the equation of fourth equation implies 10A plus B equals to 21. Subtracting minus, I can cancel this. I will get minus 8A equal to minus 16. So A value will be equals to 2. Substitute in any one equation. So second equation implies 2 times 2 plus B equals to 5. So B value equal to 5 minus 1, 4 will come. So A value equal to 2, B value equal to 1. So before entering question number 31, we have to see one definition, that is related portion of 12th standard, composition of functions. After seeing the definition of composition of two functions, we will come to the question 31 to 34. We will see the definition of composition of two functions, that is let f be a function from a to b, let f be a function from a to b, and g is another function from b to c, that is a function from a to b, a function from the set a to b, another function g is a function from b to c. F is a function from A to B, G is a function from B to C. Then the composition of F and G. Composition of F and B, G is denoted by, this is, we have to read it as G composition F. Function from A to C, it is defined as G composition F of X equal to G of F of X for all the values X belongs to A. This is the composition of function. Clear? So now from this, actually what does the composition of function means? We are defining a function from A to C. A function defined from A to B and it is defined from B to C. G is a function from defined from B to C. Then we can define a function that is composition of two functions, that is from A to C, that is defined as G composition F. G small circle is called composition. G composition F of X equal to G of F of X for all X belongs to the value A. Now we will use the theorem 2. What is theorem 2 says? Theorem 2, suppose F and G are real valued functions. We are taking F and G are real valued functions. Real valued functions, and F composition G is defined. F composition we can define. We can find the value of F composition G at the point C. If it is given, if G is continuous, actually if G is continuous at the point C and f is continuous. F is continuous at g of c means we can say that f composition g is continuous at the point C. Similarly, we can say that G composition F also continuous at C, we can say. Clear? So before that, what is composition? If two functions given means how to find the composition of functions we will find now. For example, if we are taking f of x equals to sin x. Similarly, we can take g of x equals to cos x. What is f composition g of x? By definition, f composition g of x means f of g of x. So what is the value of g of x? G of x equals to cos x. G of x equal to cos x. So f composition g of x equal to f of cos x. What is the value of f of x? That is sin x. What is f of cos x? F of cos x means sin of cos x. That is x in the place we have to replace cos x. This is the value of f composition g of x. If f is given and gs means how to find the value of f composition g. So from that also we can say f is continuous, that is sin x continuous function, cos x is continuous function, therefore f composition g, that is sin of cos x, is continuous function. Similarly, we can find g composition f of x also. What is g composition f of x? G of f of x. F of x value is what? Sin x. Sin x. Now replace x in the place sin x, we will get cos of sin x. So f is continuous, that is g sin x continuous, cos continuous, so cos of sin x also continuous because g composition f is continuous by the theorem 2. Clear? So clearly we can say here f composition g of x is not equal to g composition f of x. Both are different functions. Now we will move to the exercise problems. Last 4 problems. We will use this composition definition. We will prove all the problems 31 to 34. So we will start the question number 32 now. Question number 32. So what is the given question here? Given question f of x equals to modulus of cos x. F of 2 equal to modulus of cos x given. So we are going to prove the continuity of this modulus of cos x. So we will use the concept of composition of two functions. So I am taking first, I am considering g of x. So let g of x equals to cos x and h of x is equals to modulus of x. G of x equal to cos x and h of x equals to modulus of x. So now g of x cos x is continuous. We know that g of x and h of x is h of x are continuous functions. G of x continuous and h of x is continuous for all the value of, for x belongs to all the real numbers. G of x is continuous and h of x also continuous. What about h composition g now? H composition g of x equals to h of g of x. So what is the value of g of x? G of x is equals to cos x. Now h of cos x mean clearly that will be modulus of cos x. So we know that h composition g is continuous. So we can say that modulus of cos x is also continuous. Clear? Similarly, we will prove the question number 32. Actually, I left question number 31, I think. Okay, we will solve question number 31. Then we will move to the question number 33 and 34. Question number 31. So, question 31 is given that f of x equals to, the question given question equals to f of x equal to cos x square. F of x equal to cos of x square. Here, we are going to show that it's a continuous function. So I am taking my h of x and equals to, let h of x is equals to x square and g of x is equals to cos x. We know that x square and cos x cosine function are continuous for all x belongs to the real number. So for all x belongs to real numbers, these two functions are continuous. Now I'm going to use the concept of composition of two functions. What is g composition h now? G composition h of x equal to g of h of x, which is nothing but g of h of x value is x square. So now replace in g of x in the place x square, we will get cos of x square. So g composition of h of x equal to cos x square. Therefore g composition h of x is continuous. So we can say that cos of x square is also continuous. Clear? Next we will start question number 33. So question number 33. So what is given here, we can take it as f of x equals to sine of modulus of x. Here I am taking let g of x equals to modulus of x and h of x is equals to sine x. So we know that modulus of x and sin x are continuous functions. Therefore I am going to use the concept of the composition of two functions. What is h composition g? H composition g of x equal to h of g of x. So I am replacing the g of x value, that is equals to modulus of x. Now h of x value is sin x. X in the place replace modulus of x. We will get sine of modulus of x. Here therefore h composition g of x is continuous at all x belongs to the real numbers. So I can say that sine of modulus of x is also continuous at x belongs to R. Clear? Now the final question number 34. This question we will use theorem 1, that is question number 34. The given f of x is equals to modulus of x minus modulus of x plus 1. So we already proved the continuity of modulus of x and continuity of modulus of x plus 1. So we know that modulus of x and modulus of x plus 1 are continuous at all x belongs to real numbers. So therefore sum of the two functions is continuous, product of the function is continuous, difference of two functions is continuous. By theorem 1, f is continuous, g is continuous, means f minus g also continuous. So we are using that modulus of x continuous, modulus of x plus 1 is continuous. So we can write modulus of x minus modulus of x plus 1 is also continuous at all the point x belongs to R. So already we have proved modulus of x plus 1. How we proving means modulus of x definition is minus x, x is less than 0, positive x, x is greater than or equal to 0. We have to use case 1, less than 0 case, equal to 0 case, greater than 0 case. Similarly we have to use the definition of modulus of x minus 1. Here it is positive of x minus 1, x is greater than or equal to 1, negative of x minus 1, x is less than or equal to 1. These problems already we proved. I think this problem is the same model of question number D, third question D model. This question we proved. Same modulus function we proved so many times in the exercise 5.1. Okay, next class we will start the differentiability. Thank you all.